Okay. Um. All right. So far, I've gone through the sorting and data structures chapter in the Skianas algorithm design manual book. I was thinking of just going ahead with the next chapter because honestly, it's a bit tired of writing code and stuff. So I just wanna just read and stuff. But that's just not a good way to learn any of this stuff. So I'm gonna go on LeetCode and practice. The nice thing about this book is that at the end of the chapter they do suggest a few LeetCode problems, so that's kind of nice. So that's what we're gonna do. So now I'm looking at so there's three here. I mean, there's definitely more, but let's just do these three and see how long it'll take us. If I understand my own abilities, it's gonna take quite a while just for three, so better than nothing. So let's just get things started. Okay, so we're looking at this one. uh, Hold on. Yeah, what is happening? Okay. Well, what is it? Wait, what is it loading? And the nice thing is that the whole time I was studying in C, so I was thinking about pointers and stuff, and it's a bit confusing, but well, if I'm given the benefit of writing it in Python, which is something that I'm a bit more familiar with and honestly easier, uh I should hope things are better. Even though if I want to do things in hard mode, I should probably do it in C or C++ or something like that. I don't know why is it loading? Is this question very tricky to execute? What is it? Okay, so here we go. Uh all right. Okay. Given the root of a binary tree, determine if it is a valid binary search tree. Interesting. Binary search tree, a valid binary search tree is defined as follow. The left node contains nodes which are less than the node's key. The right is greater. Both left and right subtrees must also be binary trees. So this is valid smaller, larger. And this is false because this is smaller. Yeah, the root node's value is 5, but its right child is 4. Okay. So the number of nodes is this much, and then the values are this much roughly. How do I know if it's a So I think the question is gonna be something to do with traversal. So if it's a valid tree, when you traverse it, you will get a sorted array, right? You will get something that is sorted. Um, or I could do it even more simpler. Uh, Wait, but it says also binary search trees. Okay, I assume the binary part is not gonna be contested, right? So that means there's not gonna be a tree with like three children or something. Okay. So the point is that, well, we can check layer by layer, right? So if it's on top, then if it's okay, we go down to the next layer. If it's okay, we go down to the next layer, and so on and so forth. Um, okay. So let's just give it a shot. Let's see if there's any. Okay, let's just try it out. So value dot left dot right. So my strategy so far is that, let me just write down my strategy. Check. Is this too small? Check if current level is valid. If true, go down to next level. If false, return false. That's just that straightforward, right? So yeah. So I guess we can just do a recursion stuff, right? So self root. So we first check if the current level is valid. So if root dot val is less than, well, is more than equals to root dot left and root dot val less than equals to root dot right. So if this is correct, then we check the left sub key. Then we check return is valid BST. I think I need a self there. Self.valid is BST, is valid BST. Root.left, or maybe right, whatever. Else return false. Well, let me see if I wanna. If not, I return false, right? So if I do this, this is fine, but then it's only gonna go down to the left subtree. So I wanna check that if this is okay, I wanna check the left subtree, and then when we're done, we wanna check the right subtree. How do I do both? I guess I could just let me think. So this is invalid because this is okay and this is okay, but then we check the left one is fine. Of course, if the left one is null, so I guess you can do or root dot left root dot value is null. What's null? Input false, root value is 5, but it's right. Wait, so wait, what? Is null a thing? Is null a real thing? So it's there's none. Yeah, there's no null, right? There's none, I guess. Well, okay, wait. Maybe let's just make it a little bit more verbose just for clarity here. So left child valid equals root dot val greater than root dot left, or root dot left is none. Next one is kind of the same idea. We say that the right child is valid if the root is smaller than the right child, or that it is a none, so it's always valid. So if both are valid, and right child valid. So if both are okay, I need to check the left child and the right child. So it's not really recursive actually. It's not really recursive because I mean it is, but wait, is it recursion? I could do it recursively, but I feel like I don't have to, right? Because I could just check the next one and then be okay with it. So as long as yeah, but the point is I have to check the left. Oh my god, yep. Here we go. Time to get confused. I could do it recursively, that's for sure. That means I just check through and the moment it hits null. But the point is I don't need to how do I say? Each time my problem should get smaller. And that I'm just moving on to the next level and I don't need to return anything necessarily. So it will be like this, right? So something like this. So if right child, left child valid, then I check. And then if not, it's at reverse. I feel this works might be super slow. Because now... oh, what? Not support between int and tree node. Oops. Is not. Okay, let me try that again. Non-type has no attribute. Well, wait, what? Wait, why is it? I see. Okay, okay. Must I like? This looks so dumb. This looks so dumb. This looks so ugly. So ugly. Oh, this is so ugly. But okay, let's just see if it works. I mean, so ugly. So if wait, but wait, let me just check something. If I do greater than none, is it always true or you can't do that, right? What? Okay. Syntax. Wrong answer. Oh, shoot. So 213. Wait, 213. No. If less there, right, then is true. Okay. So this should be true, but I suspect this is what? Non-type has no attribute dot left. Non-type. Return true, right? Wait, hold up. If it's okay. Wait. Whoa, hold on. So if you are here, if the left is none, you return it's not necessarily a valid. You just say left child and left valid equals true. This is fine. I think you just say that if your root is none, that means if you are there, then you just return true. Then you're done. Otherwise you return false. What is it? Wrong answer? Wait, expected false. Why is this wrong? 222 is okay, what? No? Wait, isn't 222 okay? Wait. He's less than. Oh, not or equals to. Really? Okay. Okay, let's see now if it's correct. What the hell is the wrong answer? Okay, so it's not none, it's null. Okay. Wait, what is null? Like, it's not a... It what? Wait, what? 5460037. Wait, maybe it's not something. Hold on. Wait. 5460037. Oh, wait a second. This is invalid, but wait, hold on. The right tree contains nodes with keys greater than the node key. So it has to be. Wait, hold on. I think I just have an wrong understanding about this. So if I do 5, 4, so even if this is 7, let's say 3 cannot be here, right? Because, wait, can it? Can it be? The left subtree of a node only contains node with keys less than the node's key. Yes, the right subtree contains greater than. Both left subtree must also be binary search trees. This is funny because it's a recursive. Wait, so is it a valid binary search tree if you have, let's say, 1, 2, 3, and then you have 1 here again? Can you do that? You can't, right? Because now when you traverse it, you won't get a correct tree, right? And my submission says so in this case it will be 5140036. Now this will be 5460037, and 3 is wrong. So that means I need to oh, what the heck is happening? So that means I need to check. Oh my god. Let me get some paper. Okay, alright. Okay, so if I now do like this, 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 like this. So let's say what, 5? No, let's say this is 10. 5, 20, 3, 7. So this can't, let's say, be 9 because it will still have to be greater than. So that means 9 has to be smaller than this, but greater than this. But greater than this, but greater than this. Whoa. So when I pass on the root, did you do the contest? No. The contest today? No. I don't. Wait. I don't know what you mean. What contest? Also, honestly, I can't tell if you're a bot because your name is No Condom Chris. I have no idea. Oh, there's a weekly contest? I'm not aware. Yeah, no, I'm not doing it. I'm just started using it a while back, so you can get interviews from them. Oh wow, really nice. The week is Amazon Pay. I see. Okay. Yeah, I mean that's thanks for mentioning that. I think that's a really good thing that I should try. But at the moment I'm just starting, so there's no way I'm gonna do well at all. So, maybe after maybe after a few weeks when I'm more seasoned. I don't know. Yeah, seems like, I mean, if you might not have to do that well. Really, Amazon, really? Oh, why? I mean, that's not what I'd expect. I mean, they're a huge company. I assume they have a lot of talent, and there's huge competition to want to work for them. So I assume everyone who's on the platform is pretty much a beast at coding. While I'm struggling with BST. Here we go. That's interesting. But there's a huge shortage of. I see. Okay, well, interestingly, I'm not a software engineer actually. Nor am I trained in that really. My background is statistics and a bit of machine learning. So yeah. Yeah, but I'm still doing all these things to prep for, tech jobs, which seem to have an obsession over, algorithms in their interviews at least. Okay. So and don't have to study. Yeah, yeah. Yeah, that's what I've heard from several friends as well. Like, you don't have to, you don't have to study software engineer to be a software engineer. Of course, I guess you could pick it up on the job and eventually get experienced at it. So yeah, that's. But I mean, uh, yeah, I mean, I guess I don't know. Very much a possibility. Yeah. Thanks for the suggestion, though. I didn't know there's this such a thing. Oh, actually, it says here contest. It's probably relevant. I assume you are familiar, and what are you doing the contest? Wow. Okay, this looks really cool. Yeah, I think I'll probably try some of these things once I study up a little bit more. Get at least a good baseline coverage of the stuff that can happen, and then quickly jump into getting these things done. Oh, nice. Amazon Pay. I see. This is so cool. This is very, very cool. Yes, I do all of them. Oh, nice. Maybe just check out what? Sorry? EPI. What's that? EPI. Oh, do you mean element of programming interface? Okay, has nice code style. Wait, what is it? Wait, what is this? Oh. So it's like a preparation, I guess like a library? It's a book. Wait, it's a book? But it just says download the project. Uh, okay. Now I'm reading this book suggested by my PhD supervisor, Skinner's Algorithm Design Manual. It's a kind of a nice book. I mean, well, I haven't read a ton of algo books, so this is, giving me quite a lot of insight. Okay, thanks. I'll check this out. Let me mark this. Take a look at it. Okay. Anyway, so yeah, so now I'm trying to do this, and I thought it would be easier than what I imagined, and uh, but the idea is that I can't have a I can't have it has to be smaller than this, smaller than this, smaller than this, smaller than this. I can't have a child on the right hand side that's larger than anything on the left hand side. Reading is yeah, uh wait, what? Okay, let me see if I could uh yeah, reading, yeah, using a helper function might helper function. Wait, hold on. Okay, let me try to keep up a bit of what this is. PDF. What? Ah, is this what it is? Oh, nice. Great. Yeah, so yeah, so far I think Yeah, as usual, I'm just doing some brush up to the stuff, and what I'm truly not familiar with is graphs and dynamic programming, and I guess parallel stuff because I'm not super good at those things either. But so far, based on my past week, just the past week of practice, of studying, I've gone through more or less these things up to binary tree. So yeah, this looks like a really good resource. Let me just download that I could refer to. Oh, okay. Common tools, language, question design. Uh, uh, nice. This looks like a very targeted and practical source. It's great. Oh, that's not the full book. Yikes. Shoot. Well, that's silly of me. I thought that was like, oh, the full book. I see. Okay. Let me try to. I linked you to full. Yeah, but okay, this is silly of me, but I don't know how to click on the link because I can't. Is there a way to do it? Oh no, I can just go on Twitch. Oh my god, I'm so. Because I'm viewing all of this in OBS, which is. I'm a very incapable Twitch streamer. I don't know half of what all these things are, so forgive my ineptitude. Uh, okay, yeah, okay, I'm looking at. Yes, this one. Wait, what? This looks very fishy, but I don't know. Yep. Yo, it's 235 megabytes. What? Well, I wonder if it can even load. Like when PDFs get too heavy, it takes forever to just load and it's very annoying. Anyway. Okay, yeah, anyway, while we let that go. So where was I? So yeah, I was just checking that the right and left are in order, but that's not sufficient. As I quickly realized that yeah, it must be smaller than all of its parents. So how do I manage this? Well, if it's smaller than this, then it will be smaller than all of it's on the right? So, oh no, it has to, wait, hold on. It has to be larger. That's the problem, right? And similarly, on the left-hand side, we have the same type of issue. Okay, let me see. Yep. Oh, loads surprisingly fast. Wow. Wow. Nice. Thanks for this. This is cool. Are you looking are you preparing for work as well? Doing all the contests and stuff. Collart's conjecture. Hmm. Okay. Oh, congratulations. So what type of work are you, I mean, yeah, if you want to share, like are you happy with the new work that you get? Was it hard to find a job? I don't know. I assume you're talking about software engineering, right? Okay. Not that hard. Ah, that's good. Well, okay, well, if it's not that hard because it's not that hard, or is it because you're that good? If you're that good, then okay, well, I'm a lot happier. No, wow, that's great. Happy, very happy to hear for you. That's kind of the end goal of everything, right? Is that in the end just want to be happier. Uh, okay. I was on the lower end too. What do you mean? Went from 13k 130k to 20k. So you mean your previous job was like paying you 130k a year, something like that, in what is it, USD? And the new job is, oh shit, it's a 2x bump. Sick. Amazing. Nice. Is 130k considered low? I'm actually not sure. I guess it depends on which part of the world you're at. If you're in like I don't know, like those Bay Area. Wow, 130k is very low. Hmm. Hmm. Which part of the world are you at? 200k is average for new grad. Wow. Wait, really? Average? Average. Sick. That's amazing. For Bay Area. Yeah, okay, okay, yeah. I guess Bay Area is more or less the most, you know, the hub of it all. Okay, then it makes perfect sense, yeah. Nice. Did you have to move there? Like I don't know, did you have to move there specifically for work? Or is your life already nearby? Then it's like, okay. Roblox, Stripe, Databricks. Yeah. Wow. Wow. That's sick. Hmm. Yeah, I hear Chain Street pays obscene amounts. That's great. Server trading is 550. What? Yeah, the traders. Yes, the trader. No, I'm from there. Oh, that's cool. That's cool. All right. Now let me attempt to reach a tenth of what you achieved. Congratulations again. This is so sick. It's very inspiring to hear. Very cool stories. So you can get a solution. What? Okay, let me think properly. Yeah, maybe you can, I don't know, maybe you'd like to give some advice on how to train LeetCode, because so for example, what's the right balance between trying and, you know, giving up, and then looking at some solutions in hopes to do better? Or should I just not give up and just, you know, probably not this, but, you know, spend a lot of time on one question? Yeah. If you're not making progress, I would say give up. Yeah, that makes sense. Yeah. I guess, yeah, yeah. How long has it been? About half hour. Okay. Yeah, I think that's a good policy. I'll live by that now. Helper route. Yeah. So I was thinking about traversal initially, and I was thinking that if you just traverse the entire tree, you should get a sorted list. But that's a little bit overkill because you don't need to. Oh, now that I think about it, oh, you can't. Oh. Because if the tree is wrong right away, you don't have to traverse the whole tree. It's a waste of time. But the problem is, as you go deeper into the tree, you still have to compare with the parent. That the parent are valid. So for example, even let's say this is I don't know. Let's say this is 7 and this is 10. 3 is still wrong because 3 cannot be on the right side of 5. Which means when I think about 3, I have to think about this, and I think about that, and then everything of the predecessors. So now you compare the Now you compare to the in order. So you compare 5 to 1, 3 to 5, 4 to 3. What? You compare the in order predecessor. Huh? Wait, why would you need to compare 1? Ah, okay, I know what you mean. Okay, 1, 5. Wait, the in order traversal is 1, 5. The in order traversal is 1, 5, 3, 4, 6. Yes. I mean, yeah. Depends on what you mean, I guess, but in order traversal. I thought that yeah. The in order traversal would be that. You just go to the left and then you hit the middle and then you go to the right and then it recurses. So it's like a depth first search with the left side happening first. Okay. Okay, yeah, so that's the in order reversal. I mean in order traversal, yeah, that makes sense. Hold on. Yeah, okay. So then you compare it to the uh yeah, so BST in order traversal is sorted. That's correct. So if I do this, it will be sorted, yeah. So in the end I do have to, I mean, yeah, I understand that this one way to do it is to just do an in order traversal and then check that they are all in increasing order. But I was just considering if that's necessary. Is that okay. Yeah, I mean, okay, let's just move this somewhere so that I don't think about it. Yeah, I was thinking that because if I do traversal, then I have to do the entire tree. Even though I don't think it makes a huge difference in terms of big O, but so yeah, if I do traversal, I do the entire tree, and sometimes that's not necessary. Like in this case, I could just cut the story short because I know that 3 is not correct. But maybe if I take into account all the comparisons with the parent and Indian, I'm doing the same thing. I'm not sure. Maybe I can do a, well, are there restrictions on what the values can there be? Yeah. So the values are, I guess, one of these things that make sure it doesn't overflow or something. No, so the lower limit is enough limits. There is some. To the node, to the one node. What do you mean to the one node? Not for the problem constraint. In example 2. Yep. Sorry, I'm not following. Other restriction on what values can be there. What do you mean what values can be there? All the values have to be in this range. Like, sorry, I'm not showing. So the one node, what value can be there? Okay. You're asking me. Oh, okay. I thought, okay. Yeah, anything less than, in this case has to be less than, I guess less than, well, less than 5, right? less than 5. Okay, let me just do a simple, well, let's not say simple, because if I can't do it, then what's the point? So let's just do a sort. Wait, what? Maybe. Well, no, traverse. Maybe let's do a traverse. So to traverse, let me see if I can even traverse. Maybe something's wrong. Oops. So essentially what I care about is that I wanna have the, or rather let's do like a print tree, something like that. Well, no, doesn't matter. The weather's pretty warm today. Weird. Is there a clean way to do this? I guess I could just use a list. Is that clean? I don't know if I wanna I guess. So I could do like traverse BST root dot left plus, I don't know if this is clean, but something like this. Okay, well, okay, before we think about how pretty it looks or how nice it works, just make it work first. So okay, so if my root is none, just an empty string, I guess. Is that it? Wait, if it's none, no, sorry. So if I go down like this, you can use generators too. In it's progress on space. Yeah, it's progress. You can use generators too if you want. Yeah. So I could only just produce the next one when I need it, huh? Okay, let me just see this through first, just to. Yeah, just to put in practice what I learned here. Write it down. So here. Return here. Oh, I guess this works. I don't know. So let's say sorted list equals why is my okay? Then I guess the simplest way to check do I have a clean way of doing this? I mean, there's a few ways, but at this point it doesn't really matter. I just want to check that it's in increasing order. You could use So I guess we can say, I don't know if this is that useful. Sorted list. The first one onwards. So do, and then all the way from the last one. I don't know. We want to make sure that a less than 0, something like that. So if a minus b is greater than 0, which is what we want, so this must be always less than this. That's correct. Okay. Okay. No, it's the wrong answer. What is going on? 222 is output is true, expected false. Oh wait, so we want them to be false. Wait, so 222 is not a valid tree, huh? I guess I just put this. I don't know. Oh, there's a couple of people watching me struggle. Thanks for hope this, I mean, if you're new to this, hopefully this is helpful information, and if this has been something that you struggle with, maybe this is a nice throwback to what it looks like when you don't know what's going on. 89 milliseconds faster than 7.87%, so I'm slower than 93% is what it's saying. Okay. Less than, okay, so basically what I have, it works, but it's trash, right? Okay, that's what it means. Not, I mean, I expected that. So clearly the idea is that I do not need to traverse the whole tree. That's a waste of time. In order traversal, yeah. You know the all function? It's more Pythonic. What do you mean all? Yes. I see what you mean. Yeah. Uh, yeah, so you could technically just take one minus the other and then all it, right? Something like that. Does that actually, is that gonna be the bottleneck? I don't think so. So, yo. Returns true if all the elements given are true, else given false. Is that faster? Is that necessarily faster? I don't know. Yeah, but in this case, you have to build the whole thing, right? Okay, I see what you mean. Yeah. Yeah, I agree. I agree. It looks clean. I agree. This implementation is completely insane. That you should not do this. It's just so it's so unnecessary. But I figured that at least this stops as early as it can possibly, rather than having to generate the whole thing. But yeah, you're right. So let's give that a shot. Why not? Even though at this point I really doubt that this is the bottleneck, but well, we'll see. So I can just say that a equals to, oh wait, I can't, is there a way to, yeah, okay. No, that doesn't say short circuits. Anything is false, it just stops. Oh, I did not know that. That's very good. I didn't know that. Cool. So I just use, so what is that? I use a comprehension. So I do a minus b. Now I don't need this stuff. And then I do, what is it called? How do I write this? Just all. Ah, okay. Oh wait, sorry, this is now gonna be greater than 0. All, Oh, surprisingly, it does better. Like, okay, that's a lot better than cool. Ah, I didn't know these little things make a difference. I wonder if it makes a difference in like like an actual interview, because like depending on the language, you get all these little tricks and little speed ups that you can get from you know, that type of stuff. In terms of speed, no. Yeah, right, yeah. My point is, so okay, so like for example, like this makes sense that, you know, it was much slower than it was, and now it's much a little bit faster, but maybe it makes no difference to the interviewer, like that this speed up due to this little trick here that happens to be applicable in this case for this language, for example. Okay, it doesn't mean anything. It has to read sexy. Yeah, I know what I mean. You know, when you when you read a nice piece of code and it's like, ooh. Yeah, I guess if the idea is sexy, then that's the most important, and it like works slickly. Okay. So I mean, okay, so this approach works. But I still want to explore the way to make it more efficient. I mean, clearly, if this is an interview, the interviewer is gonna be like, oh, okay, so you do this, blah blah blah. Can you make it faster? So on. So now it's time to make it faster. Uh-huh. So again, so if I have something like this, it has to be bigger than this, but it has to be smaller than anything else before. You can't get faster than O because you have to visit every node. In this case, do you mean the checking of the sortedness of the list, or the whole problem? Because the whole problem, it does feel like you, worst case is it well, that's probably not true. It has to be like, because the deeper you go, the more you have to check above. So okay, wait, so if it's not, has to be larger than this. Has to be larger than the parent. Let's say this is, well, let's say this is 13. Wait, so this is valid. This is valid. Oh, so maybe I just have to check one extra thing, which is that it is, wait, okay, so this is one idea. Reverse, then check. This is one idea, which definitely works. Now let's try another one where I don't think I want to traverse. Is it possible for Americans to study abroad? We looked on NUS in Singapore in the summer. In the summer, what time you're talking about? Because there is a summer break as well, where there's no school. So, but if your friend is looking for an exchange program for something like August, mid-August to December, May to August. May to August is the summer break though. This is precisely the summer break. I don't wait. There are some classes, those kind of summer vacation classes, but I don't think they fall under the standard exchange student programs. Has schools in the summer. Oh, okay, really. I guess if the system is mostly like a trimester type of thing, or like you go by quarters, right? If you go by quarters, then this makes sense. Yeah, so in NUS, and I guess which follows something like I guess similar to the UK semester system. Yeah, so yeah, if you do semesters, then it's like August to December and January to May, and then in between, end of the year, the Christmas month and the summer, it's there's no school. Yeah, yeah. Hmm. I mean, if your friend is interested to visit Singapore, uh, I mean, there's always summer internships. I don't know. Maybe if your friend is into that. Okay. So whenever I have here, I want to also pass on the root, the parent information. So the root is here. Okay, this is some schools. Blah, blah, blah. Let me just maybe look at something. So let's just say large binary search. Just look at an example. Apparently my intuition for this is pretty bad still. So okay, so so let's say if I check for 42, I need to make sure that it is smaller than 46, but also make sure that it is larger than 41. How the hell do I do that? So I can't just keep track of the immediate parent, huh? I must keep track of the other side. So similarly, when I check for 64, it must be larger than... What's the... How do I distill it? BST zone is valid if its left child is a BST, its right child is a BST. The value. Its value is between the right child. Yes. Yes. Ah, so wait, but I thought that was my first solution that didn't quite work. Maybe I wrote it wrong. Okay. So you check for that. Check that for every. Yes. Yes. I thought I had that. Wait, maybe I didn't. Whoops. So my node, so I am a valid tree if my left, I have no left child. That's true. Wait. Yeah, but this is the exact same problem that I ran into. Wait, maybe my condition is wrong. That my left child is a valid BST, my right child is a valid BST. And And then my own value is between my two children. Oh. Yeah, what am I doing? This is trash. Okay, wait. So, um, I don't need to do any of this. Oh my god. Okay, wait, hold on. Let's just say correct value equals to root dot left. Root dot. Yeah, I don't need to do any of that. Is it val? So root dot left dot val is smaller than equal to root dot val, and root dot right dot val greater than not equals to root dot val. Let's just say that valid val. Let's just say that if then I can save a bit of time, I think. Yeah. Whoa, none type. Wait, but why would it go on if non type has no attribute? Yeah, because yeah, that was a problem that I had, huh? So wait, I feel like I'm gonna rewrite the same thing. Wait, then I'm rewriting the same thing, right? Oh my god. Oh my god, yeah, I'm rewriting the same thing. But wait, what's wrong with it? So initially that was my idea to do more or less by definition what it says, but it doesn't work, does it? Wait, why wouldn't it work? It has to work, right? Why wouldn't it work? Even though I still have suspicions that might not be super fast because you are deep diving in the hole at the bottom, then you kind of go up the level. I don't know. Okay. Left valid is equals to, so left side is valid. So I want to check that it's correct. So if there's no, if my left is none. Okay, so if my root dot left is none, then it's true. So I should just, but the point is, if it's not none, yeah, I'm rewriting the exact same thing. So now left is invalid. Oh, what the? What? I'm sure there's a cleaner way to write this logic, but because of this dot val issue, it's a little bit annoying. So this was exactly more or less what I had. And then the right val to me over and right. Left valid and right valid. No. You should get information from its valid root left before you can make the conclusion about left. Oh, left valid. Oh, no. My naming is horrible, but I don't mean left. This whole chunk is just to check that my root is indeed smaller than the left and larger than the left and smaller than the right. It's not about checking the left side tree, because to do that I'm checking here. So what I guess what I'm saying here is that as long as the value of the root is wrong, I don't need to check everything else. I don't need to go down to check the trees, because it's just already wrong. But I do need to take into concern if there's no left value in the first place, in which case when I check for it, it will be automatically true because the root is none. And I thought I did this just now and it didn't work for some reason. I forgot. Yeah, it says wrong answer. Yeah. Yeah, okay. Let's no, this is just typo. Let's see if it, but just now it didn't work. Yeah, it didn't work. So 5 4 6 now 3 7. Wait, so maybe my logic is wrong. So if my root left is none, then automatically left side is okay. And if it's less than the root, then it's okay. Oh, is it because I did something? Not sure. Well, no, it's the same thing, right? Yeah, it's the same thing. Yeah, then this is just pretty okay, it's a little bit tiny bit clean at this point. But something might messed up in the left subtree. You're just checking the left child node against the root. But those three conditions are they are an AND condition, right? So I need all three things to be true, that the left subtree is correct, the right subtree is correct, and the root is valid. So you're just checking the left child node against the root. Yes, I'm checking the left child node against the root. Yes. Wait, hold up. Yeah, because that was how I came into this place in the first place, is that I realized I'm just checking, but I'm not checking with the parent, right? Oh, wait. Something's wrong with my recursion. My logic is bad. Oh. Should I just make... Well, okay, I don't know if this makes a huge difference. Really? Would that make a difference? I don't think so. Yeah, it doesn't. Wait. My recursion is not correct, so everything is breaking. Shoot. How would this recur so that it goes down? Yeah, this is wrong. I must check that it's a valid subtree first. Yo. So, ah, wait. So the point is when I check something like this, say I cannot just compare this and then say that, oh, it's valid and then check smaller subtree. That's wrong. What I need to do is to make sure this is a subtree first, that this is a subtree first, then I check. Uh, hmm. I don't know if this makes any sense, but let's just give it a shot. At this point, what could go worse? What? Definitely true else. That's uh this looks so bad. uh I'll be surprised if this works. Wait, what? It's not defined? Ah, self. This is so annoying. Let me just read the question again. The left subtree node contains only nodes with the left subtree of a node contains only nodes with keys less than the node's key. That means if it's a valid subtree, so something like this. Oh, I need to check against everything. Wait, what? Yeah, my logic is completely upside down and wrong. So if it recurses down to this level and then it bounces up. So let's say this is a valid subtree, but when I check this, I'm only checking with this, which doesn't know anything about this. So I need to keep track of like the largest, which is like the rightmost child. Wait, why is this so hard? It's funny. Uh Hold on. It uh, uh, so what defines a valid subtree? The valid subtree. If Oh, I need to find the largest and the smallest. I need to dig in all the way. Oh wow. Damn, thanks for that. Thanks for the effort. Okay, let me see what you're helping out with. Uh, if not root. Yeah, okay, yeah. So you kind of need to know the min and the max. I see. If it's not a root, return. Ah, okay. It's been left subtree is bin, next subtree is bin, right subtree is max. Yeah, okay. Uh, right. Okay. Thanks so much for this, but you don't have to do any of this. You don't really don't. Okay, wait. Let me try to. So I need to keep track of them. But wouldn't this be? Oh, right. So let me just check on. So if I take the largest, uh, yeah, okay. I see my issue now. So that the point is when I check back at a slightly higher, at just like this level, I'm not looking at anything beyond, which is clearly not correct. So I would have a guarantee that this is correct, and everything on the left side must be smaller than this. So that means I have to find a max and then I have to find a min. Um, so that means what I really need to do is. So actually what I had isn't wrong per se, it's just that severely, yeah, it's just wrong. What was I doing again? Uh, yeah, so this part is completely not useful. So the left, if there's nothing to shoot, then it's so this is something like left max. Right, that means your value must be larger than the left side max. And then this would be have to be like right min, something like that. So now if it's none, I return true. If it's not none, then I will say No, I don't need. So while is not none, not is none, not is not. So let's say uh so you want to find the max element, you want to find the max element in the left uh L, you start with I don't know if this is gonna make it small or slow or whatever, but uh so you start off with the left and then you keep on going right. Uh and then the moment the right node is there's nothing, then it will be something like that. Similarly, I have the right hand side, I believe. So this will have to be like the min. Hmm. So you start off with the right, and then you go while it is. Oh wait, hold on. Bit of an issue here. Just want to make sure I have my levels correct. So if it's not none, then you start off with so you start with root actually. So as long as the right hand side is none, you can go there. As long as it's none, you just take itself. And then so alright, let's see if it works. Can we go back to, I think you're not on track. Yikes. Hold on. Give me a few seconds to convince myself that I'm crazy. What? Valid. What? Left. Shoot. Wait, what? What syntax error? Wait, what? Hold on, wait, let me check what syntax error is it talking about even? Where? Am I using my wall? Wait. Am I using my wall? Oh shoot. Yeah, this is. Wait. Hold up. Hold up. Oh, not is? Oh, it's not. Oh my god. Okay, so this works. Okay, but yeah, the mistake that I had was I was just comparing to the immediate child whereas I needed to compare with the largest element of that subtree, or the smallest element depending on the right or left or right side. Uh, so it's much faster and it's a little bit better, I guess. Yeah, with all those conditions, yeah, you're right. It's yeah, yeah. No, I fully agree. Yeah, I just wanted to just push it through to make sure that at least the idea is valid. But I agree, this is super ugly. No one wants to see this. Yes. And people won't understand. Yeah, also I don't think you'll make a good impression on the interviewer if you start to go go like this. Even though I would argue that it's kind of valid. It does, I mean, every if else is doing something useful. It's not like superfluous, I guess. Okay, well, I mean that well. Okay. So yeah, let me just take a look at what you have here. Wait, what is it? Here. Uh, okay, let me just copy paste this maybe. Mm. Uh, uh, okay. All right. Uh, okay, so if it's not the root, uh, then I will is BST min of BST max of BST. Oh, but isn't this kind of similar to, I guess it is, but it's better written. Uh, is BST, so I can just say that return I guess this is what you possibly mean. Return is valid BST root then min of BST. We could just write, well, but we could just write helper functions, right? Should we do that? Oh, no, oops, sorry, my bad. Wait, maybe I wasn't reading it correctly. What? Hold up. The point of tree problems is to build your solution bottom up. So DFS root dot left and DFS root gives us information about root. Yes. Oh, okay. All you need to do is edit the line. Uh, right. So return if it's a BST, which means that I have to do. Wait, but so if my so in my tree, if it looks like this, how do I know? Oh, I could just pass back the max. Wait. Wait. use in. So I guess it's just min of the BST. Wait, but why do you need? Hold on. Why do you need? Wait. Based off information of the two child. Yes. Wait, why do you need of? Why do you need both min and max of both subtrees? I don't understand. So if it's the left, don't you just need the left max and then the right min? Oh no, hold on, let me see if I'm making any sense here. So I'm saying that yes. Oh, wait, I think that's about right. Yes. But wait. So if it's not a root, that means it's none, then I just say that it's always valid, and then the minimum is inf, and then the maximum is negative inf, so that anything else beats it. So I need a comparison here. Yeah, left subtree max, left subtree max smaller than root dot val. And can I go next line on this? You do it like this. Is that the bad? Is that not good? Right subtree min greater. Something like this. And then return the left min and the right. Okay, I think that makes a lot of sense. Can root change our new min and new? No. Okay, wait, but if it's infinite, then we need to do something about it, right? I mean, yeah, okay, so the bottom layer is a problem here, because technically speaking, every left node will be smaller, but in this case, we want to make sure that so if so I guess I could just do a min. Max. So I guess this is technically only affecting the bottom layer, right? Because any previous layer you wouldn't run into this problem. If our left subtree max is 4 and our root value is 5, yeah, that makes sense. Okay, wait, this is getting a little bit confusing, but let's just see. We're crazy here. What? Okay. What? My. Okay. Memory usage less than. So I think the memory usage for this is a little higher. Okay. Right, but this is fundamentally a slightly different. Yeah, yeah, I get that, yeah. But it is a little different in terms of the concept, right? Because this tracks the largest and smallest value because this same function is used no matter you're checking left and right subtrees, right? So it has to so there's a bit of I guess excess memory used in terms of saving. For the left subtree you don't really care about the min, for the right subtree you don't really care about the max. Right? So there's yeah. Hmm. Okay. Cool. Cool. Okay, yeah, but that's yeah, this is an important practice because yeah, the way I checked this was completely out of whack. Okay, let's move on to the next one, and that took forever. But okay, better late than never. Let's hope we can do better each time. Thank you so much for your help, by the way, Chris. Okay, next one. You're given an array number, integer array nums, and you have to return new counts array. The counts has the property where count I is the number of small elements to the right. What? Where count I is an array is the number of elements to the right of nums I. What? Number of elements, number of smaller elements. Ah, okay. So in this case, 5 has 2 and 1, so that's 2, and 2 has 1, and 6 has 0, and 1 has nothing on the right. Okay. Don't do IC hearts. Oh yeah, this is, oh shoot, this is hard. You're gonna need to travel before hearts. Okay, but if you nowadays say that, I have to give it a quick punch, right? Just to see how hard it is. Okay, let me just give it like a 10 minutes try. And if I fail at it, I mean, obviously I can do a shitty job and, do like a, what is this? Like an n square thing. But, okay. Let me think if I can do anything better than n square. So n square is obvious. Well, you just count everything and then you get like a half n square. So let's not do that. Even though one might argue that even something silly like that might take me a while because I'm just so trash. uh you know what, let's just get warmed up, let's just get warmed up and not be presumptuous. Who knows, maybe I can't even do the basic one. Okay, count smaller. um Return, so I guess I have my output. So for L in list. Okay, so for every number in list, um uh I can build something. Well, I could use what you shared with me just now. So that's no, enumerate. I think we need to enumerate this. So enumerate would be index an element. Wait, I can't do this, right? Nums. Okay. So compare. This is obviously a bad solution, but whatever. Nums. We have 2 loops here. It's pretty bad. For actually, is there a simpler way? I'm pretty sure you could like I don't know, use one of those. Okay, but you need a maybe like a iter2 library or something like that to get those things. So you're 0, that means you are taking index +1 onwards, and then you will say for element underscore in, and then you check element less than element, and then you say that out index equals sum of compare, something like that, and then you return out. See if it works. Probably wrong because shoot, this list in assignment index out of range. Why am I supposed to do one of these -1 stuff? Okay, fine. So if so if like this, and then you count to the right, and then when you reach the end, there's nothing to the right. Right, so if index equals len nums -1 out index equals 0, I guess we could just force a special case there, and otherwise, oops, I think we should be okay here. What? Unsupported. Oh, sorry. Sorry. Wait. No. It's not that. Silly of me. Of course, I can't even. Okay. Let's just chill out. Let's just chill out and do the easy thing. Okay. So, so if you're at the last element, where the index. So if this has 10 elements, last index is 9. So it'd be 9 and then 0. That's fair. Otherwise, we will take 0 from 1 onwards. And if it's 9, we will not do anything. And then for each of the elements, we want to count the element that are less than your current element. And then you sum the number of true. Okay. Why is this taking so long? Oh, because they're testing out like probably tens of thousands. And then to fish out bad algorithm. Time limit exceeded, of course. Okay, so this is cool. They don't even accept my solution. Okay, now let's give the problem a second read. Okay, so immediately, I guess the intuition that I have is that, well, if let's say you have a long list of numbers. Okay, let's say you have a bunch of numbers, and then you have a number that is larger than the previous number, and then you found that one already. So everything else smaller than that number will also be smaller than this number because it's larger, with the exception of the values in between. Okay, I feel like maybe this requires like you need to be somehow use dynamic programming for this so they don't have to recompute stuff, maybe. Using like a memorization type of thing, maybe. Wait, no, hold up, no, because This is under this chapter, right? Which is just basic stuff. Okay, never mind. Let's just try the next one. I'm gonna take Chris's advice and just skip. But I feel like this is gonna be hard as well, right? Because it's 1, 2, 3. Oh, I don't know. Medium. Looks like an old enemy, but okay. Given two integer array pre-order and in-order, where pre-order is the pre-order traversal of a binary tree, in-order is the in-order traversal of the same tree, construct and return the binary tree. Pre-order means you get the node first, and then left, right. In-order means you get left, then itself, then right. Output. Wait, what's the output? Return the binary tree. Where you go 3, 9, 12, now 15. Ooh. Interesting. So immediately I feel like I already don't understand the question because I have no idea why you would need both pre-order and in-order to do this. So I guess there's a chance. I guess the idea is that you want to make use of both information. Alright, I feel like this is gonna take forever. But okay, better just practice, I guess. So if I know the pre-order, okay, let's just think about it. If I know the pre-order, can I construct the tree? Not necessarily, not easily at least. I see. Wait, hold on. Okay, I see. Okay, wait, this is very weird. So let me just draw something out. Like this. So if I do a pre-ordering, I will do this first. So from the pre-order, I know the top. Wait, let me just get the pre-order. Let me look at is that a long example? Okay. Right. So this is a nice example. Yeah, okay. So like this. So the pre-order will be 25, 15, 50, 15, 10, 4, 12, 22, this. Okay, I see. And then there'll be 25, 50, wait, 25, 50, 35, 31, 44, 70, 66, 90. Okay. Yeah, that makes sense. So the problem is that if I cover the tree and I just look at it, I have no idea if it's when it terminates and stuff. I guess we could use the value to be smart about it, but it looks a bit tricky. So we should use information to tell us when it kind of terminates the termination of a subtree, right? Is when it jumps across. Because when it jumps across, let's say let's look at here. When it jumps across, so okay, for pre-order it will be A, B, C, D, E, oh no, A, B, D, E, H, I, C, F, G. And for in order it would be, well, it would be D, B, H-E-I-A-S-E-G. Okay, so the moment we jump from the left subtree to the right subtree, what do we notice here? Okay, cool. So we know that the root is gonna tell us where the right. So the pre-order is gonna have the root at the first, and then the in order is gonna have the root somewhere in the middle, and then so that would denote the left subtree. So similarly, wait, can we say that? Can we say that? Because so let's look at the B subtree now. When we see B happens, and then D, I see. This is not so clear. D. Maybe I should just write down a small example so that I can intuit this. So in order, sorry, D B H E I A F C G, and then pre-order, A B D E H I C F G. Very good. So if I just look at these flattened version of the tree in some sense, what can I say? Because I know the pre-order, first thing is gonna be A, so I know A is on top. And then the left side is gonna be B. I know that much. But I can't tell if D is further recursed down or to the right. Right? But in order will tell me the in order will tell me which one is which, because if D is greater than B, it will be on the right. So this tells me that it is on the left. And now E, because E is after D, so I know it terminates and it goes to the right. And then H compares to, and H goes before E, which means that it goes to the left. And I goes after, which means I know it goes to the right. And then C is to the right, which means that, oh, but it's to the right of A as well. So, okay, yeah. Oh my god, I have no idea how to do this. I can roughly intuit this, but this is... Okay, can I maybe code this? Can I code this procedure out? So what I have written is just... I can see some notations. Oh, surprising, there's 5 people viewing it. Wow. And then I should just do like... Well, what I want to do is to find this level, right? What? I have no idea. Am I supposed to like... Is this some... I wonder if this is like a standard thing. I guess it is, but... Am I expected to be able to derive this on the spot if I've never seen this before? No idea. I guess I am supposed to be able to do it because... I mean, it's the chap... No. This is standard? Okay. Yeah, but I wonder if I have any chance of figuring this one out, you know. It's a bit like, let's say, I don't know, if I've not heard of hashing, for example, and then the question requires hashing, then there's like no chance, right? Because like how, you know, you're not gonna invent hashing on the spot. Don't worry, if you do contest every week, you get good. Yeah. I'm, you know, that's why I'm just trying to train to make this a habit and give myself some motivation. Okay. Okay, let's spend a bit of time here. Hmm. Is it like a very smart way to do this? Let me think. So the next thing you want to find is C, and it's all the way down here. And so all these values are going to be smaller than A. You're going to find the smallest value. No. Not the smallest value. Not the smallest value. Not the smallest value. That's a very dangerous mistake. So in this case, my pre-order is 2515 so the next thing I want to find is 2550 and 50. And 50 is on the right hand side of 25 of in order, which I know, but I don't know which one it is. I suppose so what does 50 tell what? Let me think. There has to be a way. There has to be a good way to do this. 25 25 50. Okay, I have a little revelation is that this is gonna be the right subtree, and this is gonna be the right subtree. Is that useful? No idea. But even then, it doesn't help that much because once I figure out the right subtree, I still gotta figure out the left subtree here. And they're gonna be broken up. 412. So when the number drops, when the number rises, this is when it goes in. Wait. Oh, there are little runs of increasing orders. Wait a second. Is that wait, does that even work? So what I'll do is I'll just take, so the point is that at the end of it all, you have runs of increasing numbers. So like 412. In this case, it would be 412, 1824, 3144, and 6690, which forms the bottom layer of your tree. And then you remove those things. And then now you go up, you will see 1022, 3570, and then you remove those things, but then you don't even need in order, right? Or is that just a red herring? Tricky. I don't know. Feel like that's a trick that could work. I don't know. Let's see. Wait, I don't know. It doesn't feel like it will work, but okay. Optional tree node. So what I could do is I could build this list and then just do an insertion into the tree, right? I don't think you guarantee the tree's balance in the question. Really? Uh, does it matter? Wait, let me see. Oh. Wait. Wait, I'm confused. It's not even a search tree, is it? It's not even a search tree, that's why you can't do this. Ah, I can't do that. Because if it's a search tree, then you can, use a structure. But it's not. Yeah, it's not even, so it's just, so I should just think about them as completely just like, I don't know, just like letters or symbols. Shoot. Okay. Okay, now it makes sense. But no, but I do have the benefit that they can be in or I see. So it's about the spacings. So for example, 15 will be always come before 7. So similarly in this case, because the order is 1, 2, 3 or 1, 2, 3. So the difference is the two positions here. Okay, so I think maybe a good example was the alphabet example that we had just now. Okay, so thanks for that. Yeah, it's not even sorted. What am I what am I doing? Okay, so H will always come after I. Okay, and they will be, in the case of in order, they will be separated by the root, which is in this case E. So similarly, D will always come before E and it will be separated by everything in between. Yeah, I think actually that's more or less the idea, right? Okay, but how do I, it's not concrete to me what's exactly I'm talking about. Can we build? Pre-order gives you the root they need to figure out the two subtrees. Yeah, that makes sense. I mean, yeah, I agree. But then I will need to kind of how to say. So yeah, the pre-order gives you the root. You're absolutely right. So A, and then I would need to find out all these things. I need to find out where this is, which is separated here, I guess. And then I will need to do this, where this is B, and then I'll take B. Oh, shoot, you're right. And then this would be the left. Okay, let me just quickly write down what the feeling is. So pre-order will give us root. Then we will build tree for left subtree, which are where the list is before the root element in the in order list. Yeah, I'm getting a better intuition as I think more about this, but still pretty shaky at the moment. So let's see. What should BitTree return? It should return a node. So it will return a tree node with value equals to pre-order dot the first one, I guess, something like this. And then the left node will be build tree. The left node will be build tree on some element based on the left subtree, where we will find out. So it will be something like in order all the way up to some number. And then my right subtree will be self.build tree of the in order of that up to the index. So let's just call it index. I don't know. So you just need to find index. Yeah, I agree. Yeah, Chris. Yeah, I mean, it's, of course, it's by no means the best choices of questions, but yeah, but I just feel like at this stage where I'm at, which is where I'm just kind of slowly getting better, this doesn't really matter what problems I choose. I just choose a good mix of things that I can handle. Then I just feel like at the start it's more important to just keep doing than to think too much about what to do. Of course, I don't want to go too far beyond my abilities and get no progress. Yeah. Yeah, maybe in order difficulty is a good idea. Maybe I'll try that. So okay, so we build a tree where the pre-order. Okay, wait, hold on. Let me try to split this up here. Check out the top 100 list. Yeah, I will. Interestingly, the last element is gonna be that last element too. Left, right, then the in order. Okay, so I just need to find the element. So a so I guess for if e equals to pre-order, this is what you want to do. First is LeetCode with friends, second is mock interviews. Binarysearch.com and prem. Oh, I don't know those sites. Let me check them out. Ramp. Hmm. Yeah, wow. Yeah, it's a lot. Oh, this is a lot. Okay. Uh ooh. Hmm. uh it is straightforward if you can say things about where the root and subtrees are in different traversals. Yeah. Learning properties of tree traversals is straightforward if you can say things about where the root and subtrees are in different traversals. That's right. Yeah. So I feel like this is kind of how it works. Hold on. So I am trying to find X6 biweekly. All right. Thanks for the help, Chris. Congrats on your new job again. Glad to hear that it's all going well. Hope you have a nice week ahead. Okay, so build tree node. And then at the end of it all, it'll be empty. If it's empty, I feel like I'm gonna run into a lot of trouble for this. If it's empty list, so that means if I split, okay, if I split here, then let's say I do the right subtree here, and then it's gonna give me the root. Then it's gonna give me uh uh wait. So this is gonna give me the root. I'm gonna take this pre-order, and then my left subtree is gonna be, now I'm gonna build it based on this. The left subtree is gonna be 1 to it's gonna be this one to this point, including itself. And then right tree is gonna be onwards. Okay. And then for the left tree, for the in order, it's gonna be 0 to index, I don't know. What? Oh. Well, if it's hold on. So if the length is equals to 1, then it'll just be reorder 0, and then left equals none and right equals none. Syntax is never closed. Shit. Yeah, of course index run auto. Of course. Why am I not surprised, huh? Okay, so let me think. So if I have a long chain here, and then I have another long chain here, and then my pivot is here, and then my root is here. I want to take 0. Okay, so I want to take the pre-order 0, and then to build the tree, to build the... Wait, hold on. To build the tree on my right, I will need to take, yeah, index plus 1. Wait, this is index. It'll be index onwards. Wait. No. It'll be 1, 2. No, what the heck? Wait, to build the left subtree, it will be... okay, let's think about this. So A is here. This is index. So it'll be 0. Oh, wait. To build the left subtree, it will be 0 to index. And the right subtree will be index plus 1 onwards, excluding this. And then it will include this. So it will be 1 to index plus 1. And then from here, it'll be index plus 1 onwards. Now the problem is, if there's only one element, so something like FCG in this case, down to E. So if there's only one, or let's say there's 2 elements. Okay. Let's say there's 2 elements. So AIG, okay, then I take, yes, then I'll take B. Take D. EHI. So in this case, so now I'll take E. Then I'll take E. So this would be 0 to 1. In order 0 to 1. And it will be 2 onwards. Wait, why is this wrong? Hmm. 0. 1, 2. What happens when the root is the last element of in order? Oh, that means when we only have one subtree, why it gotta be like that? Okay. So yeah, if the root is in the last element of the in order sort, yeah, then I'm screwed because I cannot do this. Index. So index is last. That means it will be. Shouldn't it be? Wait. So let me just figure this one out. So if it's in the last one, then I will take. So let's say this is 9. Onwards. So my left subtree would be everything. Oh wait. Index. I mean I could. How do I make it an empty list? Well. Yeah, how do you actually make it an empty list? So that it doesn't include itself. Is there any easy way to, what happens when you have I mean, do I really wanna? Okay, let's do a ugly way first. That means it's in the last guy. And then let's say that Wait, I just want to check if my logic is correct first. Because the logic is it sound? So if it's the last element, then what I want to do, so it look something like this. Then I want to go all the way for my left subtree to be before that. So it would I know it would include it. That means it would be all the way to the back, correct? And my right tree would be empty list. Shit, what do I do when I have empty list? I don't know. Okay, it doesn't matter. Let's just keep on going first. And the left in sort would be from 0 to all the way to index. That's still fine. And then my right would be my right in sort would be an empty list. Okay. Feels a bit silly, but I guess it works. This would be right pre. And then right in. Okay. So we have this, but we still need to deal with what do we do when we have an empty list. When we have an empty list, what do I return? I return. That means there's nothing there. Uh. Yeah, just return none. Don't know. Oh, it's correct, but it's bad. I guess you want len order in one in if, by the way. I don't need that, right? Yeah, because the pre-order and in-order length, they will always be the same. That's the thing. So I just need to check one of them. So it's faster, slower, less than, blah blah blah. Okay, so generally it's not a good solution. Okay, I mean I'm happy that it worked, but okay, let's see what we can do better. Interesting. I don't necessarily know if I can do better here. Is it because of how I deal with this? This is just looking for the element. Is there like a fast function to do this? List Python search what do you say, index of match or whatever. Okay, is there something like this? Oh, there is. That's also quite sad. NumPy. Okay. Uh-huh. Index. Oh, I've visited this link probably countless times. Never didn't stick. Yeah, let's try that. Maybe that's what it is. So let's just comment this one out. Then we say index equals to in order dot index pre order 0. Does it work like that? Yes. Unless there's some okay, so it's much faster, but the memory is less. The memory is bad. Why is the memory bad? Am I storing shit? What? So this is it. So the problem is because I am the memory probably comes from the fact that I'm doing it recursively. Okay, let's think if there's any better way to do it. Like wait, how would you not wait. I guess you could do it iteratively, right? Just so you look at the list and then you say, okay, A goes to the top and then B goes to the next. Hmm. Hmm. No, that's not that's but it's the same thing, right? Wait, where was that thing that I saw just now? Okay. Uh, 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 uh. Hmm. Okay. Well, where was the example that I had just now? Shoot. Okay, good enough. What's this? Google Lens? No, I don't need. Let's see. Wait, what the heck? So here, thank you. Thanks for dropping by. So here, can I build? Um, huh. Uh, hmm. Must be a better way. I mean, could it be easier to find out the order and then do an insertion slowly? That means, I mean, that's my next best idea. So far, I'm doing this recursively, and I mean, it works, but that means I want to get the level order. Yeah, how do I do that? Uh, hmm. Interesting. Mm-hmm. So I mean, this works, but it's not really. No, I mean, it's fine, but not that good, huh? Memory though, and it's not that fast either. Something's wrong. Why is it not fast? Nothing I'm doing here is slow, right? Uh, hmm. 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 Memory demand is a bit high here. Uh, Hmm. But maybe that's just the like the size of the tree. How do I check that this? How do I check? Hold up. Solution? Oh, I have to. Oh, there's a solution here. True. Mm-hmm. Yeah, so this is what I built my solution on. Array to tree. Oh, you built a hash map. What? Wait, what? You built a hash map? Uh, wait, but I don't understand. How do you if left select the pre excluding in order? What is array to tree? Ah, so it's recursive as well. Okay. Hmm. Why God, why? Is this really a medium problem? If you get this question, they do not want to hire you. Yeah, I can't imagine coming up with this in 35 minutes interview. As in, I get the idea, and I guess mine works, but I don't understand. I guess I don't understand hashes intimately enough that I can see that, oh, I can do a hash and make things fast here. Because the way I see it is that, okay, so I have all these things. I'm building this. So I am. Oh, I don't know. Wait, what's the complexity for this method? So on average, I'm cutting down I'm doing how many cuts on average? I'm doing log n times, and then each time I'm doing 2. Wait, isn't this? Wait. I'm crazy. It's not, definitely not log n. And minimally is n, right? Oh my god, I'm so tired. Approach 1. What's approach 2? This is approach 1. Okay. You first set the element of pre-order as the root, then construct the entire tree. To find the left and right subtrees, it will look for the root. It will look for the root in order, so that everything on the left should be on the left subtree, everything on the right should be right subtree. Both subtree can be constructed by making a recursion call. Correct. Worth noting, while we recurse, we should choose the next element in order to initialize as the new root. That's correct, because this is the current one has already been utilized. That's correct. Mm-hmm. Mm. Oh, wait, what? No, what? Huh? I guess. No, because wait, I'm not doing the same thing, right? I hmm. Build a hash map to record the relation of value index. What the hell is value index for in order so that we can find the position of the root in constant time? The position of build a hash map to record the relation. Oh. Wait. Ah, wait, really? Is that what it is? So, uh, uh, wait. No. So now he's just saying we need to find. So this is fine. Build a hash map to record the relationship of value to index for in order. Yeah. Oh my god. Yeah. I mean that's an obvious case actually, right? So I will just do like a uh okay, wait. Hold up. Okay, I think this, let's just save this solution that works first. Okay. Now let's do it properly, so to speak. So in order element to maps to I, so that you can load it in constant time, and then define I don't know. Uh free mm. So now my index just becomes mm, don't know. Ah, shoot. No, it's not faster, it's heavier. Okay, because now I'm using a dictionary, I guess. It is still correct, so okay, let's see the solution. Build a hash map. Initialize an integer variable pre-order index to keep track of the element that will be used to construct the root. What does that mean? To keep track of the element that will be used to construct the root. Okay. Implement a recursive function array to tree which takes a range and returns a constructed binary tree. If the range is empty, return null. Initialize root with the pre-order index, and then increment. Wait, and then increment? Recursively use the left and right portions of in order to construct left and right subtrees. But why? Simply call the recursion function with the entire range of in order. What? Wait. So, huh. Initialize an integer variable pre-order index to keep track of elements that be used to construct the root. Wait, so if I do this, then when I break this up, what do you mean that it we used to construct the root. Pre-order index to keep track of the element that we used to construct the root. Oh, so you don't need to pass through lists. Oh, then you do the right tree, left tree, then the right tree. Oh. Oh, that's... Oh, shit. That's pretty smart. Pretty smart. Okay, okay. So that means all this does is take a in order and then a pre-order index. What? Okay, let me try to code that up. Pre-order index and in order underscore, I guess that's fine. Arrange, so I don't even need... What's non-local? Okay, okay, let me just get this down on my own. Okay, I kind of get the idea. So the idea is that if I have this, I build A, and then I pass this, and then my next key is gonna be B, then I'm gonna cut, and it's gonna be D. Oh, okay. That's cool. I guess it's a different approach. This, I think it's faster. Okay. So in that function, what I want to do is, take the index, and take the left and right. Okay, let me delete everything. So to build that tree, I need to initialize my tree node. Well, let's just say node equals tree node. Val equals to pre-order index. No. I want to say that it's pre-order. No, it's pre-order of pre-order index. Okay. Then my node to the left would be array to tree. Now my pre-order index is gonna be +1, and then my left is gonna be 0 my right side is gonna be my right side is gonna be oh wait wait this is dangerous. Wait, this is dangerous. Okay, come on, keep it going. Okay. No. Okay, so the recursion should be that my hmm this is uh Corresponding indexed val so the corresponding index would be from so let's say this is A pre-order, and this is A, so the index would be something like I, and then this would be 0 to index minus I. Minus 1, and then it will be plus 1 to the end, which is just so what if it's in the first position somehow? So what if it's A as well? Then I will be 0 to 0 minus 1. Then it will be none. Okay, I think this is more or less the idea. Yeah. Oh, sorry, not length. It's not 0, this left, of course. Whoops. Yeah. And then so I need to do is just return the same thing lah. Right, so return array to 3, 0, and then the right would be the max length index. Okay. Oof. Referenced before assignment. Wait, what? Isn't it? Didn't I write it here? Local variable root index reference before assignment. How do I? How do they do that? Oh, okay, they have more or less the same thing. Oh, they have more or less the same thing. Oh, they have more or less the same. Wait, but how do they get non-local? What the heck? The heck non-local? What? You need to do that? Wait, isn't there? Wait. If I, but the point is I declare it here, no? Then this function can use it inside, isn't it? Then I call it. I can create a function to track it. Okay, it's a small problem. Let's try to figure it out. So my root index is okay. I could just carry the root index, right? It's a bit silly, but we could do that. Ah, no, we can't. Oh shit. Because it depends on how often we run this thing. Oh boy. So we need like a counter or something. Like a generator. Maybe we can do that. How do you write a generator? Like a yield function. Right. Yeah, you still need to use the non-local. Ay. Must I do that? I guess. So what? Uh It'll be hello. I see. Okay. Eh. Eh. uh I guess. I mean, this is more or less the solution that they give, right? So it should be very good. Yeah, okay. What I didn't realize is that so this approach is based on going left all the way first, then to the right, then the root will follow the order of the pre or the list, of course. Whereas what I had was to uh hmm. Okay, I see. All right, so this has been cool. Only took, something like 3 hours for 3 questions. But it's better than last time. Last time I think I took 2 hours for one question or something like that, something pretty horrible. So this is a little better. Getting a bit a hair more familiar with these things. So I'll come back next time, and we'll be faster. Okay. And thanks for all the help for everyone who chimed in. And if you've been watching, that's cool. See you guys again.